Now, what if we have to add 5/8 and 3/4? Reiterating what I just said, but, okay. We have eighths of a whole and we have quarters of a whole, right? So those aren't commensurate. They're not measuring the same thing. People are tempted to add the numerators and add the denominators. It makes no sense at all to do that. Just by this, if you add the denominators here, you're going to get 12/16. Well, 5/8 and 7/8 are both bigger than a half. You got more than a whole. If you got 12/16, that will be 3/4. Well, 7/8 alone is bigger than 3/4. Okay? So, for that sort of reason, you never add the denominators. But you do need to get a common denominator. Now, it's simple enough. We know that we can multiply 3/4 by 2/2. Because 2/2 is just 1. When you multiply by 1, you don't change the thing you're multiplying. Okay? So just multiplying by 1 here. So that's 5/8 plus 6/8. Now that's just a trick. Multiply by 1 by using whatever number you need to match this denominator with this one. Okay? Easy enough. It also says that, well, 1/4 is 2/8. So if you have 3/4, each of those is 2/8, each of the three, so you have 6/8. So there's common sense behind it too, not just an abstract mathematical operation. So it's kind of good to know that. And that gives you then 11/8, which can't be reduced. Now sometimes you can do this as mixed numbers and stuff, but everybody knows how to do that. And if you don't, you'll review it. I don't think anybody's going to have trouble with that. Okay. Now let's just go ahead. What if we wanted to do 5/8 plus 4/3? Well, in this case, you can't build a third out of eighths. Okay? Cut something into 8 pieces, cut an identical thing into 3 pieces, and you can't build one of these out of these. Here, if you cut 2 identical pieces into eighths, you have 5 of them, and then one of them you cut into fourths, and you have 3 of them. Each of those fourths is 2/8, so that works. It doesn't work here. Okay? So what you have to do is you got to cut both of these. Okay? Now the formal operation is to, now when I multiply by 3/3, I'm taking these eighths and I'm dividing each one of those into 3 pieces. Okay? And when I do 4/3, multiply by 8/8. So I'm taking each of these thirds and dividing it into 8 pieces. Okay? Well, each of those pieces is a 24th. Okay? If I take every one of these 8 pieces here and divide it into 3, I've got 24 of them. If I take every one of these 3 pieces here and divide it into 8 pieces, I've got 24 of them. And then I can add them. Okay, so that's 15/24. You got to watch me, incidentally. I can get really careless with my arithmetic. So if you see me do something wrong, you can't say anything because we could identify you on the video. Okay? And, you know, you end up getting blackmailed, your whole life's ruined. Okay? For trying to correct me, but, you know. Excuse me. That's not going to happen, but, you know, privacy still. It's important. Okay, so anyhow, you got 15/24 here, right? If you see me make an arithmetic mistake, just jump up and down, point at the board, and wave your hand. Do something to tell me that you got a mistake, or raise your hand and I'll stop the video. Okay? We'll go on. Okay, so you got 15/24 here, and now you've got 32/24 here. Okay? It's 4/3, okay, I looked at the wrong thing. Okay, and that comes out to 47/24. And that won't reduce because 47 is a prime number. Everybody know what a prime number is? That's okay, it'll come up. We'll get the greatest common factor and stuff. Okay, so that's what you do, and basically what you're going to need to do for the 2 assignments on fractions. It'll be due on our second day of classes.